Hey everyone, we're going to take a look at the ripple effect puzzles, the second to last set from Hexagony, and we're going to start with the example. So ripple effect is a fairly straightforward type on the surface. In each of these regions, we're going to put the numbers from 1 to the size of the region. So this one will contain a 1 and a 2, and this one will go up to 5, and so on. However, the only other rule is that when you place a number, so let's say we put a 4 here, then any other instance of the same number cannot be within that number cells in any orthogonal direction. So this 4 then eliminates these 4 cells, and this cell. Note that it says nothing about the diagonal, and we could still put a 4 on the side. Alright, so now that we've established the rules, the obvious starting point to this example puzzle is this single cell region, as it must contain a 1. That's going to eliminate a 1 from this domino, giving us the orientation of it. Now, we can also just pencil mark in, we could pencil mark in everything, but I'm just going to stick to limited cells and cells that give us eliminations. So then if we look at this 3-cell region, this 2 and 1 are both seeing this cell, so it's a 3. This gives us then a 1-2 pair. But note that regardless of which choice we make for this 1-2, this cell's within 2 cells. This is a fairly common pattern with straight lines where the largest number will see out the edge no matter what. And this is something that's going to come up again in the contest puzzles. So that's going to give us the full orientation of these cells. If we look at the cells that the 2's reach, we can then place this 2, which is going to give us this 2, and then get a 2 pair right here. This 2 and this 2 combine to give us this one, which is actually going to resolve the 2's. We can then make more progress into the bottom, and we have this pair and this pair. And that's all the 2's in the puzzle. And this is another thing that often happens with a ripple effect. You'll place a couple copies of one number, and it will propagate through the rest of the grid and fill those spots, and then you can then make progress with another number. This doesn't always happen, but it often is something that can be done. So the next really critical thing to look at, and I'm going to highlight these with a surface, is these 4 L tetromino regions on the outside. All of these must contain a 4. And the interesting thing is, if I were to say put one in this corner, if we look at the eliminations, we then get one here and one in one of these spots, and now it's broken. And we can do the same to eliminate the corners from being a choice for the 4's. And now we can look again and see that there are 2 options. There's either these cells that I've highlighted in yellow, as picking any one of these will force it around the rest, or the pairs in green. However, this goes a step farther. If we consider this S tetromino region, and we take the yellow set of 4's, well, right here eliminates these 2 cells, and this one eliminates this last cell. Therefore, the yellow set is incorrect. And we can then place a pencil-marked 4. We can actually place a 4 exactly by looking at this tetromino with the 1, by placing the 1 here. 4, 4, 4, 2. This is then a 1-3 pair. This is also a 1-3 pair. The same deduction we did here will apply here to give us this entire group. This 3 exerts pressure. This is a 1-3 pair, immediately resolved by the 3. The 3 is now placeable, the 4 is placeable, gives us the bottom. We can then place a 5 here, the only 5 in the grid, as the 1 is eliminated. And that 1, being the last placement in this F pentomino, will give us the remainder of the digits. So this is kind of a tricky opening ripple effect that I wanted to use for the example. I don't know how to make easy ripple effects help. Really, my entire point was to make a clueless ripple effect, to show that this was something that could come up, and that do not expect a lot of numbers on the contest puzzles. So speaking of the contest puzzles, let's get right to the first one. So this one is the highest low point value puzzle out of any of the types on the contest, at a 30-point ripple effect. And it's only this little circle, like that's the entire puzzle. But you'll notice that there are a lot of 5-cell regions, and it's mostly clueless. The obvious starting point is this one, which then gives us a 2-3 pair. And then you're kind of out of luck. And what you have to realize, and this is why this is a 30-point puzzle, this is something that's immediately obvious to me, but one, I made this, and two, I've seen similar ideas. So just like with the acre puzzle, if we consider these two regions together, there are 2 4s in these two regions. And you'll notice that they cannot both be in the same column, which means we have a 4 that exerts pressure on these 2 cells. And given that there are these 4 O tetrominoes, these 4 squares, we're actually going to highlight this in red. None of these cells can contain a 4. And I'm going to stick with this highlighting just to show the fact that there's a 4 on this line eliminates it from here. We then get a 4, which if we go back here, again, will eliminate more options from being 4s. Once I place a digit, I'll remove the 4. This 4 gives the same kind of elimination on this side. And, we get these 2 eliminated, and this one. So we actually will place a 4, which will give us more eliminations. And this is the second real sticking point, sorry. Again, we can consider these 2 regions, and now that this rightmost column is no longer part of the possible 4s, the same deduction eliminates these 2 cells. So it gives us this 4. But, since we've also placed this 4, this can no longer be a 3, as it would eliminate all of the remaining cells that could be a 3. So we get a 2, we get a 3. This is then a 3-4 pair. This is then a 2-5 pair. My numlock is turned off, apparently. Don't know how that happened. This is a 2, which then creates a 2-4 pair right here. It also creates a 1-3 pair. Now, we can't say for certain which of these spots will contain the 2, but we can say that this is a 2. That gives us a 2 pair. Might as well pencil mark in these 4s. And once we have these 4s, we get this one, which gives us this one. 4, 2, 2. We then get that pencil mark. And I'm actually going to eliminate the red cells at this point. I don't think they're going to be too useful from now on. Pencil marks will be enough. So again, we can propagate some 3s around the grid. We have this 1-3 pair. This 4 eliminates a 4 from up here. We get these 3s, which means we'll now place this one. This 3, along with these pointing 3s, give us this. And you can see how ripple effect, if you can get those initial placements, often does ripple out and just cascade. It can be very satisfying to unravel one of these. We get this as a pair of 3s. This is a paired 4, which means this is a paired 4, due to this combination of things being seen. This 4 actually gives us another pair. Let's see. Yes, this 2 is going to resolve the 2-5. That's no longer a pencil marked 2. It hasn't been for a little bit. Let's see, we get this 1-2 pair. 3s are over there, but that doesn't seem very useful. let's see, we have a paired 2 in this S region in the corner. Of course. This 3 is already exerting pressure here, which resolves the 3 in the F. We're then missing a 1, 2, 5. And the same deduction we did with 4s to break into the puzzle can now be used with 5s on these regions. As even this one, farthest one away sees all of these cells. So all of those are seen by a 5, placing a 5. Which then gives us this pair and this pair. Let's see, what else can we do that we haven't done yet? That's super obvious and I'm just not seeing. Yep. So this pair of 4s eliminates this 4, which is actually going to place a lot of digits around the puzzle in quick succession. These two 4s eliminate all but 2 candidates in this S. It's always a useful thing to do, eliminate candidates. This P now has only 1 3 remaining. We also have this 3 pair. Let's see, what else is there? Unless this cell is a 1 or a 5. So I guess if the cell is a 2 or a 3, or I should say it can't be a 2, obviously, but if this cell is a 3, then we would immediately place another 3. That doesn't seem useful here, but that kind of step can be useful sometimes. That's not a 4. Yes, 4s. These two 4s actually place the 4 into this bottom region, which eliminates one of our options for the 3. We then get a 3 pair here, with no other options for it. We can also say this cell is not a 2 after we put in this. Because if this is a 2, this is a 2, and the combination eliminates all possibilities. So that's not a 2, which means the 2 goes in any of these cells. However, the 4 seeing here, and the 3 seeing here, and the 5 already being in the region, gives us a 1. This is the other major thing that can happen in a ripple effect. We're in a region, all of the large numbers have been eliminated, and you're only left with a small number. So that gives us another 1. We then get a 1 pair. We also get this 2 5 pair. Let's see. This could be a 2 or it could be a 5, and can't quite say which yet. Doesn't seem to have any. There doesn't seem to be any influence in this region on 4s yet, or 2s. However, this 1 that we placed gives us a 1 pair, giving us a 2, 2 5. This is then a 5 pair, this is then a 2 pair. Note that we actually just outright have a 2 3 pair, placing the 1 and a 5. This gives us a 1 4 pair, eliminating a 3. Ripples to the other side of the grid. 3 elimination, 3 elimination. In fact, this is eliminated by everything else in the row. It must be a 1. See, now we're moving. This one actually is the only thing left for a 4. In rarer cases, the only value left for a cell will be on the larger end. Always something to be aware of. A 1 3 pair. Let's see. We actually get a 2 3 pair, giving us the 5. This 4 actually is going to resolve the rest of this middle part, or the majority of it. This 3 is going to give some progress. One of those is a 2. We have no idea on 4s in there. Nothing else actually gives us influence on 4s yet. This 2 elimination is going to give a lot more. All of this is just seeing what candidate values that we've already noted are eliminated from cells. And you'll notice the last placement is right there in this X pentomino. And that is how you solve the 30-point square ripple effect from Hexagony. Not the cleanest solve, there's a little bit of staring. But remember, this was a 30-point puzzle. If you've seen the score table, you'll know that the second puzzle is worth 60 points. So if this is 30, what does a 60-pointer look like? This is what a 60-point ripple effect looks like. So this is the only puzzle that I have pre-solved to have the solution path fresh in my mind. And hopefully that will allow me to showcase the difficult to spot logical steps in a way that flows nicely. So this is not a live solve, or mostly not a live solve, and hopefully that is still a useful showcase. So we're going to start with the very easy deductions, where we only have single values remaining, and we'll then put in these 2 dominoes. And just like with the Kakaro and many other puzzle types with the hexagonal grids, this cell cannot be a 1 or a 2 without eliminating both values from this domino. So it's a 3, we get a 1-2 pair, and the very first deduction that I placed into this puzzle, the thing I wanted to include as the break-in, was how this domino interacts with this one and this implied domino. Now, if you spotted that if this is a 2, we would then place a 2 in each of these cells by elimination, then good for you. This is a 1. Then this is a 2. This 1 sees these 3 cells, so does this 3. So we get a 1-3 pair. We'll also then get a 2 in one of these 2 cells, and this is where I'm going to break out surface mode. And we're going to color all 3 of these cells. Now, why am I coloring all 3 of these cells a different color? That's because tracking what must be what is going to be very useful for this stage of the puzzle. We know that, I'm actually going to use all of the pencil marks for these. We know green must be 4 or 5. And that means that this cell, and this cell will all be seen by this 4 which Therefore, one of these is a 4 or 5, or is the same value as this cell. Again, regardless of which of these it is, all of these are seen by this cell. Therefore, this is the same. So this is a 2, 4, or 5. This is a 4 or 5. And that's about as far as these steps initially go. But you can take it a step farther and now say, well, from this green being a 4 or 5, well, this is seen by 1, 3, yellow, and green. So it must be a blue cell. And once we get this as a blue cell, we can again state that it's 2, 4, or 5. However, if we look at yellow really closely now, and we look at this region, if this cell in particular, this yellow, is a 4, well, it sees all of these, and this one we'll see over here, and this region has no room for a 4. Since it doesn't work for a 4, the same logic will apply if yellow is 5. Therefore, yellow is 2. And now we have green and blue as 4, 5 pairs. Okay, so this next step is really hard to spot, and it involves this cell. So let's cycle through every possible value for it. It's in a 6-cell region. 1, immediately eliminated. 2, eliminated. 3, eliminated by this pair of 3s pointing up here, eliminating these. Therefore, we get this as a group of 3s, and this being a 3 would eliminate every 3 from this region. So it's not a 3. Is it a 4 or 5? Well, it's not green by this group, and it's not blue by this cell down here. Therefore, it's a 6. And the fact that we know this is a 6 might not seem very useful. But the fact that we have that elimination is actually going to be very handy shortly. As now we are going to propagate around blue. So this cell in this region has two possibilities. This one in the middle eliminates these two green cells. This one eliminates here. It could be 4. Blue could be 4. So this is not yet eliminated. Regardless of which it is, this cell will eliminate these two from this upper region. So one of those is blue, eliminating these two, leaving these two. However, notice that if this one is blue, we are eliminating all blue options from this region. And if you were solving this on paper, you'd probably be noting this with like A and B. Or the way I did it was on paper in my test solve, which took me like 12 minutes to get through, knowing some of these early steps, like the break-in and the fact that these two regions were very important places to look. That still took me about 12 minutes. This is not blue. So we now have another definitive blue placement. Okay, from this definitive blue placement, we get this. We have another paired blue placement here. This is not blue. None of those are blue. That's not blue. So we get another paired blue placement. No, no, no. We get another paired blue placement. And you can see how pretty much getting one blue cell is going to give us almost the entire rest of them. Okay, so what else can we do? That is the question. What else can we do? Well, believe it or not, this cell that I'm highlighting and unhighlighting here, similar to the 6, only has one remaining value. 3 sees it, 2 sees it, green sees it, blue sees it. Therefore, it's a 1. So we then get a 3 pair here. We do not know which of these is a 3, but that is enough to resolve this entire chain here. Give us another 3 pair and another 3 pair. This cell being eliminated from this 3 and this one by the paired 3. Now, this cell being eliminated by the paired 3 is not 2, it's not 1, it's not 3, and it's not blue. Therefore, it is green. Therefore, this is definitely also green, and we have a green pair here. So let's mark that these are definitely a 4 or a 5. We can also place a 1 here, as it's the only remaining cell value left. We can then also note on this region on the side that there's only one cell left for a 1. Let's see, we have a paired 2 in this top part. I'm trying to see. Okay, this being a green gives us a green here, which is going to place us 2 3s, 1 here, and then 1 in this cell via the immediate elimination. If we then look at eliminations on the same region we just placed, there's only 2 possibilities left for green. Again, we don't know which it is yet. If we look at the top region, this being green forces it into here. So again, we don't know which it is, except we do. These 2 definitely green cells, which we know are 4 or 5, and we have been propagating this information, are 5 cells apart, which means all of our green cells are a 4, and our definite blue cells are a 5. This is then also where the 3 will go in this region, the 2, the 5, the 5, the 3, the 2. And at this point, this very difficult puzzle is kind of just going to collapse. I'm still going to keep our definite cells highlighted, as I think it will be a useful way of tracking what is already seen and what isn't seen. So we don't know for this green, but we do know these 3 are 5. Let's see, can we have progress on the left side yet? Not 5, not 5, not 5, not 5, not 5. Therefore, this is the 5, and I believe that is the final 5 we will have to be placing into the grid. We can also resolve this region. The 2 evolved numbers is placed, giving us the remaining ones. Not 4, not 4, not 4, so 4 goes into one of these two. Again, we don't know which quite yet, but the fact that we have a 6 in this region in the top right, well, this sees 1, 2, 3, 4, 5, and 6 all within, so we actually get to place a 7, which I think placing that 7 is really cool. 3 only has 1 spot left, 2 has 1 spot left, 4, 6. That's the entire left side of the grid resolved. Let's see, 4 eliminations, only 2 possibilities left there. I think the place to look is probably going to be along the bottom row to look for any major eliminations. In fact, this cell at the top sees 1, 2, 3, 4, and 5, so it must be a 6. This sees 1, 2, 3, 1, 2, and 4, so it must be the 3. Both of these are seen by a 4, so 4 and 4. And to finish things off, we have a 1, 2 pair. We'll resolve that in a moment. This 2 sees all of these cells, so 2, 1, 2. Only 1 spot left for a 1, only 1 spot left for a 3. And to finish it off, 6, 7. And that is how you solve the 60-point hexagonal ripple effect from Hexagony. So even knowing what I was doing, this still took me over 10 minutes to walk through and explain. The really critical thing to find are essentially this hidden 6, and then a couple other pairs and eliminations on the top to eventually get these 2 cells that you know are the same value and either 4 or 5 to kind of collapse the space on which of 4 and 5 all of these green and blue cells are, which will then resolve the entire bottom in pretty short order. I'm extremely happy with this puzzle as a construction. This took me a very long time to get to work. There were a few failed constructions where I had 3s seeing each other from fairly early on, or the very last cell broke. But I learned from those, and I was able to salvage pretty much this entire opening. This was the opening to the puzzle in all prior drafts, and I'm very happy that I managed to get that to remain. So until next time, where I'll be covering the password path puzzles from Hexagony and essentially completing the set. Until then, later. Thanks for watching.